Your slides are ready, sir. Josh Judd.
Hello again. So Warp Mechanics does a lot of private label stuff for major integrator partners. Many of you won't have heard of us because we sell things through Hive Solutions, for example. They do the entire server layer for Facebook.com. You've probably heard of Facebook, but they don't really know storage very well, so they hired us to help them do storage. A lot of other Fortune 500 companies have done that. So Hive Solutions is over $10 billion a year company. They've got a lot of resources. Warp just did the major engineering work for them on the storage side. We don't really sell direct. We always sell through some kind of a partnership. But for you guys, we come here in person because that's just how we roll. What we do for commercial customers is produce turnkey systems that have the server layer, the storage layer, the operating system, Luster, everything pre-configured, but we give them the keys to the kingdom. So we deliver as an appliance, but we maintain the personality of a fully flexible Unix system. We don't try to obscure the fact that we're running a Solaris-based operating system on our controllers and Linux on our OSSs. So what happens after the system is turned on and stood up is completely flexible. Put this in perspective. A system that one of our customers stood up that's equivalent scale to the system in the lower left corner. They spent about 6 months getting it online. Our equivalent system takes, 6 days because it's been pre-built and pre-configured and pre-tested in Hive's factory. So that's what we do for non-traditional HPC customers, but you guys already know how to build supercomputers, so the primary value for you guys would be our ZFS array. This is just like a normal RAID array. It's got 2 controllers, it's got a bunch of disks in it. The difference is it uses open storage software on the controllers, ZFS, instead of running a proprietary stack or a hardware RAID controller that's going to fall further and further behind the industry and innovation. This supports both RAID and NAS, so you can take this exact same shelf, flip a switch, and turn it into an NFS server or an iSCSI server or whatever you want to do with it. It's a unified storage platform, I guess you could say. Supports Ethernet, fiber channel, and InfiniBand interfaces. I'm sure this shelf looks familiar. You can see an example of it at any of our competitors' booths, probably. We all buy things from the same contract manufacturer. So from a hardware standpoint, it's really the exact same shelf you would get elsewhere. We just do factory direct pricing on it. So tends to be a little bit less expensive, and we let you guys have control over the operating system on the controllers instead of trying to say, here's our proprietary operating system. So when we sell it, it's called a Warp RAID or a Warp NAS, depending on which software bit you flip. Has, the same number of slots that it would have if you bought it from anybody else, obviously. 2 Sandy Bridge Intel-based controllers with PCI Gen 3. You can get 240 terabytes in a single 4U enclosure, so very, very high density. 2 petabytes per rack if you want to rig it as archival storage. So very high density. I think it's more exciting when we look at it as a ZFS hybrid array that uses non-volatile RAM for the ZFS intent log. Had an interesting discussion earlier with one of the Oak Ridge people, and he started to say he wasn't really completely on board with SSD as a write accelerator. Neither are we. We don't use SSDs for write acceleration at all. You tend to burn up SSDs from a writeware standpoint. We just use NVRAMs for write acceleration. We use high capacity SSDs for read acceleration. So we force feed the SSDs with the data we think is most likely to be read soon again. And then the rest of the array we just put in nearline SAS 4 terabyte drives. If you've done the SSD and NVRAM architecture properly, the hard drives themselves essentially become an HSM solution. You write to the hard drives and very rarely will you read from them again. So the hard drives are mostly archival. And since this is supposed to be a marketing presentation where we, pitch something at you, this is what I would pitch. 3 different configurations of that array, ranging from, $60,000 for a quarter of a petabyte of archival storage. I think that's a pretty good price point. You could get a full rack, 2 petabyte rack for $500,000 at that kind of price point. All the way up to a pure SSD solution for 10 times that price, but the ability to do a full petabyte of SSD in a single rack is fairly unique. So for anybody looking to do a deep analytics application, if you want to be able to do random writes and random reads over a very large data set, I think this is probably the most cost-effective solution in the industry. So with that, any questions? Any comments? Any rotten fruit to throw because I'm standing between you and dinner? So, all right, I'll turn it over to the next vendor.
Thanks, Josh.